Welcome to another edition of Math Fun Notes. In this edition, we are looking at this problem. Here we have two functions f and g, both defined on the real line, and they both take real values, and both of them are assumed to be differentiable. We know that limit x goes to 0 gx is equal to 0, and limit x goes to 0 g prime x is equal to alpha, which is not equal to 0. So let capital Rx b is equal to fx by gx, and we suppose that limit x goes to 0 capital Rx is equal to small r, and limit x goes to 0 capital R prime x is equal to beta. We have been asked to find limit x goes to 0 f prime x divided by limit x goes to 0 g prime. So we have to find this ratio. So since Rx is equal to fx divided by gx, we know that fx is equal to Rx into gx. So taking limit on both sides of this relation, we get limit x goes to 0 fx is equal to limit x goes to 0 Rx into gx, and that is equal to limit x goes to 0 Rx into limit x goes to 0 gx, because both of these limits exist, and that is equal to r into 0. Limit x goes to 0 capital Rx is equal to r, limit x goes to 0 gx is equal to 0, so we get 0. So we get this fact that limit x goes to 0, fx is equal to f prime x is equal to r prime x gx plus g prime x rx by the product rule. And now we take limits on both sides of this relation. So we get limit x goes to 0 f prime x is equal to limit x goes to 0 r prime x into limit x goes to 0 gx plus limit x goes to 0 g prime x into limit x goes to 0 capital R x. Now limit x goes to 0 r prime x is equal to beta, limit x goes to 0 gx is given to be 0, plus limit x goes to 0 g prime x is equal to alpha, and limit x goes to 0 rx is equal to r. So limit x goes to 0 f prime x is equal to alpha times r. Therefore, limit x goes to 0 f prime x divided by limit x goes to 0 g prime x is equal to alpha times r divided by alpha. Note that we can divide by alpha because we have assumed that alpha is not equal to 0, and therefore this is equal to r. So we have shown that limit x goes to 0 f prime x divided by limit x goes to 0 g prime x is equal to r. It's a good point to stop. Thank you.